How to graph y equals the cube root of x. This is Tom Reardon, math teacher from Ohio. You will need graph paper and a pencil, and press pause anytime as needed. If you don't have graph paper, you can download this PDF at this website, which can be printed with 20 grids on each side. So y equals the cube root of x. Start with a grid. We encourage you to make a table. And these are the 5 values that we are going to use to start. You may wonder why we picked those numbers. Well, we're trying to find the cube root of numbers, so we're looking for perfect cubes. So go ahead and pause and complete the table. Hopefully these are the values you got. Notice you can take the cube root of negative numbers. So let's go ahead and plot the points. So 8, 2, the cube root of 8 is 2, cube root of 1 is 1. The origin is on there, -1, -1, and -8, -2. But right here, what does the graph look like? Is that a straight line there? So to investigate that, we're going to use 2 other numbers, 1/8 and -1/8, to see what's going on there. And you probably, again, figured out why I picked those numbers. Those are perfect cube fractions. So the cube root of 1/8 is a half. A half times a half times a half is 1/8. And the cube root of -1/8 is -1/2. And so go ahead and plot those 2 points. And you can see it kind of flattens the curve around the origin. So it's like more of a curve here and more of a curve there. We do say that these points are symmetric about the origin. We talked about that in the x cubed graph. To illustrate that, we'll look at the table, and then we will look at the points. And then the table here, and those corresponding points in orange. And then these in lime green. So that's what we mean by the points are symmetric about the origin. So let's go ahead and connect the points. And you'll notice when we connected, the curve is flattened there. So let's go ahead and look at some terminology. The origin on this graph is called a point of inflection, just like we have one in y equals x cubed. This is where the curve changes from concave up to concave down. Concave up right here before the origin to the left of it. Concave down afterwards. So it's like a half of a smile right here and half of a frown right there, and this is the point where it changes concavity, right there, point of inflection. All right, so now we're ready to look at the cube root dance. So we'll go with 5 points, starting with the point of inflection. And then our dance will be right 1, up 1, the cube root of 1 is 1. Right 8, up 2, because the cube root of 8 is 2. Left 1, down 1, the cube root of -1 is -1. And left 8, down 2, the cube root of -8 is -2. Again, we'll draw the curve, remembering to flatten it around the origin. All right, so now we're ready to go ahead and look at domain and range of the cube root function. So here we have the graph and the table right here. So we'll look at the domain first. And you can see that if you look here, all the real numbers have a point either above or below it, or right here at the origin. So the domain is all real numbers. And we usually write that with the script R. The range kind of goes slowly, but all the y values have corresponding x values, so all real numbers for that as well. So the domain is all reals and the range is all reals. We invite you to interact with another video in this series.